Hello, ladies and gentlemen. Please come in and take your seats. We're about to continue in a few seconds. Please take your seats. Hello to the second morning session today. My name is Harold Altmanspacher. I will be the chairman of the speaker of this session, who is Anirban Bandyopadhyay. So you see I have done some training on that name. He is from the National Institute for Material Sciences, not far from Tokyo. And Anirban will talk about Dodecography. Dodecon means you will say that again. It means 12 in Greek language. So he's talking about 12 orders of magnitude, 12 orders of frequency oscillations in EEG. Please welcome with me Anirban Bandyopadhyay.
Could you please ask to close the doors?
To close the doors, yes.
Okay, so good morning, everybody. And as you can see in the first slide, there are two bright objects that you are seeing are two artificial brains that we created in our laboratory. And they are talking to each other. They talk to each other 24/7. And we monitor continuously what are they doing. Don't worry about its consciousness. We are not looking for consciousness, but why are we making artificial brain? We'll get into that. But to the right corner, you are seeing some of the human subjects are there, and they are wearing a aluminum foil cap. So that is only because we do not want any external electromagnetic interference when the DDG measurement is ongoing. Many of you are present in my previous talks, and you see that I always start with this slide. You might have got tired, but I have not, and I never get tired. Because every time I present it, I find from the audience some critical questions. For an example, a few months back, I was giving this presentation and telling that, look, many of us may not have these neurons inside our brain, still we could be conscious. And then one person said that, look, there is a thin layer, at least a thin layer of the brain survived. And with that, I could do all the information processing. So it could be packed. But actually, the density of neurons for every single species is constant. So you can't pack more information to suit that I should have a brain. So who among us, of our friends, who have got brain or not, nothing to worry about, because ultimately, he could be conscious. So that inspires me every time to think differently. What could be the origin of consciousness? Is it really the matrix of neurons, the circuits made by neurons or something? So these are different examples. You know the famous Chinese lady's example who didn't have cerebellum. And example goes on. But before we talk anything about consciousness, or we try to understand the brain signals or information processing in the brain, we need to get answer 4 questions. What is unit of information in the brain? Is it beat, qubit, or any other kind of new information structure that is fundamental in our biological structures? And we have not looked into it. Because you know 99.99% researchers in the world, they consider it is beat or qubit. And then they try to build circuits. Since 1990s, neural circuit theories have come. And what is the unit device? The second question. What is the unit device? Is it microtubule? Is it membrane? Is it synaptic junction? Or it could be a cluster of neurons? Or a particular kind of symmetry? What it is? The third question is how brain integrates information. So is it like, for an example, integrated information theory? You saw the first day presentation. They take information as bit or qubit, and they integrate information by probabilistic theory that came in the 1960s. So you take the probability of observations, connect them together, add them together, and build up. So there are many such theories. Which one is correct? So we have to freeze on that. And the fourth question is, what is self-awareness and how is it achieved? Since Stuart has not asked me to talk about self-awareness or consciousness, only DDG, so I'm safe here. I'm not getting into any debate. I will safely pass and describe the technologies. So I will limit myself in question number 1, 2, and 3. Okay. So you see here, many years back, nearly 16, 17 years back, we did the experimental measurement on microtubules, and there is a water crystal that is vibrating, blue color, that is in gigahertz. Then red and yellow balls are tubulin proteins, and you see megahertz, and then C-termini or other ionic channels outside in kilohertz. So these are classic textbook, like if you have read your dispersion relation in your school days. So this is a classic example for that. Below, towards your left, it is TEM, transmission electron microscopy, by which you can see the phonon fluctuations live. And to the right, it is quantum tunneling. So many of you know, if those who don't know, the specialty in our laboratory is we wirelessly pump electromagnetic signal whenever, whatever the measurement we carry out. Say we are doing quantum tunneling measurement, we pump electromagnetic signal to find out what is the resonance frequency, and at resonance frequency, what is the local LDOS, local density of states or other features. So this is largely what microtubule is all about. And then we get into inside microtubule, just we take one tubulin protein, and we can look into its, I call it music and dance, because we are applying electromagnetic signal and wirelessly with an antenna and simultaneously measuring the tubulin. So you can see the quantum tunneling images, how it changes as a function of frequency. So this music and dance cannot be separated, and that happens at the atomic scale in the quantum domain when we are imaging it. And then when we published these kinds of results, that we should not be limited to milliseconds signal, because our conscious experience is 50 milliseconds, so neuron is firing at 1 millisecond. So I mean, in the last couple of days, you have heard many, many lectures, and our time domain is limited to milliseconds, never faster than that. So when we published this kind of results in 2011, 2012, then people started asking that if you take the microtubule out from the neuron and put it in a Petri dish and do the measurement, what is the guarantee that same thing happens inside the neuron? So we started setting up the laboratory and started publishing papers from 2014-15 onwards. Series of papers are there. So we have a setup where you can see the green color big tube. So we measure the electromagnetic signal emission and transmission. And why this is so big? Because you need amplifier very close to the location where you capture the signal. And the left side, the probe is a patch clamp, standard device used by the neuroscientists. So we have one coaxial probe and the neurons, and then simultaneously we capture how the signal processing is happening. And then we came out with this particular model. So Lapik in 1907 proposed that neuron membrane is doing all the information processing, and 2016 we came out with the proposal that by series of experimental evidences and series of papers, we argued that you have to go inside the neuron membrane, where you can find, this is the old model, and then when you enter inside, you can find very ordered unidirectional microtubule bundle, and there is a beautiful beta spectrin 200 nanometer gap. And what happens is 250 microseconds before the neuron fires, you can find out the polar communication that is happening through the neuron, single neuron, and among the neural network. So for that, we had to use another technology. It is called scanning dielectric microscopy. It was invented in Japan in 1995. This instrument gives you picture. For example, I'm looking at you. I'm seeing capturing the photons in my eyes. But you know, in astronomy, they look at the sky and they can take X-ray photography. So that is just X-ray. So that is 10 to the power 16, 17 hertz or that. So if I believe in the conventional neuroscience, then the middle picture that you see is what you would see, that ion is transmitting. So neuroscience is never wrong. We are not saying that. We are just saying that look at the right side, the video. If we take the megahertz or the gigahertz time domain, what is happening in the neuron, then you will see lots of vibrations are taking place even before the neuron fires. And you see that in the middle, there is no ionic transmission, but the dipolar transmission is seeing, and you are able to see the circuit. So we went on publishing this kind of results, several, suggesting that there are several ordered, very organized architectures inside the neuron. They are not liquid, and we should trust that. Now what happened is we imaged the electromagnetic density states and different kind of electromagnetic density structures. One problem with neuroscience is that if you physically touch the neuron and you hurt it, it's a living system. So as a physicist, I never liked it. But for biology, there is no problem, but for us, it's a huge problem. If I touch with probe, I know I'm changing the signal processing because please understand that I did my master's in astrophysics, and transition were many steps. So when first time I started seeing neuron firing in our laboratory, and I saw that I switched off the light, and I saw the neuron fired. So I understood that what kind of biology was going on around. And when I asked those engineers who do the cell culture in our institute, in the nano foundry, I asked them that neuron fires here and there whenever it wants. If I switch off light, if I shake the instruments, the Raman instrument was nearby, if I shake it, neuron fires. Well, after all, it's a living system. It can fire anytime. You can't have a then how those papers are published and those things? Oh no, that is, we consider that kind of practice. Okay. So I mean, as a physicist, I can never enter into biology. So what we did, we started new type of experiment where we will never touch the neuron. What we'll do, you see the experimental setup below? So what we'll do, with antenna, we will electromagnetically resonate, and then we send light and see how photon rotates. You know optical vortex. So photon goes straight, and if there is a periodic electromagnetic density difference, then the photon rotates and you get a vortex. So our language could be that. So what we can do for different materials inside the biological structure without touching it, we can see. So we can see the vortex assemblies. So the more the density of periodicity, you see smaller circles, and longer distance, you see bigger. So angular momentum, phase, everything could be studied from the external systems. So you can study the whole neuron, something like this, okay? So we come down to a particular system, and we started considering that the unit, fundamental unit in the brain or biological system could be a helical symmetry. We are not saying just microtubule or DNA or collagen-like systems. Wherever you have a helical system, then the photon comes and generates the vortices. So basically, when we are saying optical vortices, I am not proposing that brain is an optical device. So there are several research papers are getting published that brain computes by photons. I'm not promoting that kind of hypothesis. What I'm suggesting is that using photon, you can measure the creation of vortex. What is vortex? Suppose you have a still water and you throw a stone. You see the ring is created. So this is a two-dimensional ring. It could be three-dimensional also. We will get into that. But first, I would like to tell you one thing, that if we talk about quantum, we need to talk about geometric phase and not dynamic phase. For an example, a pendulum you oscillate, the phase that is that it contains is 360-degree phase because it is periodically oscillating. You may say that it is a dynamic phase, but in the quantum systems when you go, then you cannot say it. You have to get into geometric phase. Geometric phase means how the molecule survives its quantum states. So what happens is molecule have an outer boundary, it interacts with the environment, and it goes down slower. An internal part is very fast vibrating. So both of them interact with each other and oscillate periodically. You can't measure it. So you have to do Aharonov-Bohm interference measurement to get this phase. And this particular phase is called geometric phase, and it is responsible for any quantum phenomena that you observe anywhere. So whenever you want to do any quantum experiment, we have to redo our experimental setup completely differently so that we can measure this kind of geometric phase and its effects. And that's why it was very difficult in the initial days to understand microtubule, because what I saw, and me and my postdocs in 2008, 2009, is microtubule is like a living system. Its frequencies, 9-band, triplet of triplet frequencies are shifting, and its phase is also shifting. How do I do the measurement? How do I conclude? What should be the structure? So it went on years after years. One fundamental difference that you will find in our experiment in the papers is that if you see the red-blue color image, you will find the horizontal axis is in megahertz and vertical axis is in gigahertz. So we apply different type of scan, different types of gigahertz frequencies, high frequency, and observe 1,000 times slower domain, what is happening. Never what is the conventional practice among physicists, that where you frequency you pump, you observe there. No. And you measure the shift. So you see hundreds of measurements were carried out, and we measure the shift and find out what is the periodicity that could be the exact representation of resonance. So starting a phase sphere was not an entertainment for us. It was an essential step. It was an essential step to include all possible fluctuations. So I could see that it is modulating its frequencies, but that also has a limit. So in this way, Komal Saxena and Daya Krishnananda, they worked for 5 years, and they zoomed down to a 3D clock assembly. So even in this case, smaller size sphere means faster clock, because if there is a system point, it will take smaller time to come back, and bigger sphere means longer time. So then there is a phase quantization. So when Stewart says triplet of triplet, or we say triplet of triplet is a fundamental signature for an intelligent systems component, or intelligent life form, or intelligent information processing systems component, we say frequency. At the same time, we also say that phase is quantized. In case of microtubule, tubulin protein, or neuron, whenever you send an AC signal, you will find that phase is shifted by n pi by 4. So that is multiples of 45 degree. So then it becomes an automaton. So we measure the phase shift using optical, and then we go on finding all possible modulations that can happen and generate the structure that could safely represent all the possible vibrations and that are happening. So once we know that, we come to a point to tell what should be the most fundamental device. For an example, if the photon travels in a straight line and you have a helix that is just a single helical pathway, you will see a circle. If there is a dual helix, it could be made of like protein, water, and C-termini. All of them are making spheres. So you have 3. So you get to the last one where you create a 3D hologram-like structure that actually represents all possible vibrations and systems. So this is another reason why we consider that nested helix or helical triplet could be the fundamental of the information processing unit. And we physicists are never satisfied if you tell a particular structure of a device is the fundamental unit. We always ask that what is the Hamiltonian? If you propose any new system, I don't care. You tell me the expression of Hamiltonian, I will figure out all its possible properties. So we have written the Hamiltonian below. You don't have to worry about this complexity. Just look at in the middle central line, you see there are 12 holes, 12 singularity points in the phase sphere. So this is actually what happens when you pump microtubule with electromagnetic wave. So what happens is 12 phase singularity regions are there, and they burst and create signals. So that is the fundamental property. So when we mean that what is the unit device in any biological system or brain or whatever, we say that helical symmetry. We don't say this particular component, that particular component. How do you make it? It's your choice, but it must follow this Hamiltonian. So about this, we are fixed. Now, if you want to make it with planets, you take big planets, black holes and something, and create triplet of triplet, phase quantization, and follow the Hamiltonian, then I'm very much okay with it. I don't care. So this is how it goes on. So what we come here is, you know that for the first two structures, Nobel Prize has been given in 2020, because earlier we believed that photon goes straight, then photon rotates, and then photon generates vector. We enter into the domain of tensor, and we go ahead. So by now, I have given answer to two questions. The first question is, what should be the unit of information? It's a 3D hologram of vortices created by any field. It could be electric field, magnetic field. It could be mechanical soliton based. How you do it is your choice, but you create this kind of vortex hologram. Second is, you should have a triplet helical symmetry. So helical symmetry is important, not what kind of device. Now the third question I will go, that how do we integrate this information? So in real system neural network, you would see, I showed you schematic, right? But this is a low resolution, but this is a live. If you have a neural network or analog network or triplet helices, you see hologram that is 12 different planes or icosahedron, that is the hologram generated by the system. And we experimentally measured it, and we built a computer. At the end of my talk, I will demonstrate that how research to understand brain information processing could lead us to build several incredible technologies. So this is for entire neural network. You can see live blinking. So you can observe the operations of neural communications. Earlier used to scan, used to take microscopic picture. Now what is the vibrational picture you can see live? And the final thing that I have to tell you that if in 2014, first time I sliced brain with my own hand, and then, of course, dead rat, not human. Just sometimes misinterpretation. Okay, so I sliced, and then I saw that neurons are one inside another and totally lumped. Okay, and one thing I understood as a physicist, whoever has imagined that brain is a circuit, definitely a biologist. A physicist can never ever say, it's a mess. It's an absolute mess. Which neuron goes bottom and come out to the top and something, those are written in the textbook. These are all misleading. Just like first time when I proposed that inside microtubule there is a solid structure, I think without Stewart there was nobody in very good institute, I do not want to name. They are very famous professors, I do not want to tell their name. They said, no, neuron is kind of a membrane is there, inside microtubules are floating. I said there was one person, Hirokawa-san, from Japan. For 30 years he worked, he is still alive, and outside Japan he is absolutely not popular. He showed absolutely concrete structure, 50 nanometer gap each microtubules, and all directed in one direction. So forget about liquid floating randomness. We are talking about a concrete structure. and you can image it, measure it. Now, if there is no circuit, then how one neuron can communicate and see others? See, you can respond. I'm not a programmed device. I have not prepared my lecture beforehand. I came here, I started talking, and I don't know the next sentence that I will talk. Okay, I'm looking at your face and then thinking, okay, I should go in that direction or that direction, and I'm cooking it. So, so I'm creating a thought process, a thought structure, and matching with my thought structure and creating it instantaneously. How am I doing it? If I do not, my neurons at different information systems do not conclude all types of processing within a few milliseconds. Okay, so that's why we started looking into microtubule and started taking quantum image and change the frequency. So you see the frequency is increasing. Just see the magic, what will happen after some time. In megahertz, we started seeing the protein dynamics. And in gigahertz, we will start seeing the water channel inside and its dynamics. And I can vanish the microtubule on a quantum surface by choosing particular frequency. Now let's get to the other. Okay, so this is DNA. And we selected the frequencies, and we vanished it at particular frequencies. You see some of the nucleic acids are appearing, disappearing, and after some time at certain frequencies you will find almost gone. So we have switched back and forth. So you have atomic flat surface, it is gone. So what is the advantage of this quantum clocking? This is 2006, Turing first proposed this. We did experimentally for biological systems, but in quantum it was proposed long back, long before we worked. How it is important? Suppose there is a far distant neuron. By one neuron, microtubule bundle can resonate with other and can transmit and communicate. There will be no interference in between because you can switch on off particular structure by doing that. Okay, so let's get back to DDG now, because I think that I have given enough introduction that what is information, what is device we talk about. So 2014, we published this paper. You have seen Stuart present this work. So I'm not going to explain what does this result says. It is a triplet of triplet band at various different scales, and 10 to the power 6, 7, or 8 orders of magnitude variation. You see similar symmetry. That's why I always say we should not focus on particular type of device. What device? We should focus on symmetry. What kind of symmetry is there? That should be the important thing. That should be the point of discussion. If we collude our brain with the device structure, then it will be very, very difficult. So in 2020, this is my friend, now my friend from Florida, one person, they called me. He took a spectrum analyzer you saw yesterday. It was kept in the demo section. If you could touch your brain and you could see the megahertz oscillations. So this person, that is the result. He took the photograph of this measurement and sent it to me in Japan, because he searched this triplet of triplet. He found one stupid guy in Japan is shouting for 6, 7 years. So let's send him. He called me over phone and told that I saw this. In my stature as a scientist, I would never do this, right? Because I spend so much money and so much resources to do that kind of measurement. So many engineers. If you try to do it in any other laboratory, you will 7, 8 years will be gone. I finished it in 4 years because there are so many engineers available in NIMS free. I don't need to write project funding. They have 30 years of experience to do that kind of device. So after all this, some person who is an amateur scientist or something purchased some instrument, touched his head, and got triplet of triplet. I got it. It was very. First it was very annoying. I said, no, something artifact, something. And then I checked in my room. I also saw triplet of triplet in my forehead. And other places, I don't see it. So immediately we arranged and some budget. And in India, we started doing human subject experiment. And that is how DDG was invented. So basically, if it's a sphere, that means you can think of a sinusoidal wave. If there is a nested sphere into that bigger sphere, Then for a certain time, you see that another waveform generates. You have seen this photograph in time crystal papers. So we call it polyatomic time crystal, by which you can represent a complex dynamic systems where different kind of dynamics are phase connected. But I told you that I have to give you answer for integration of information. For that, just bear with me a little moment. So we will do some little mathematics, very simple mathematics. So this is that somebody has given you these spheres. Spheres means frequency with phase. They have given it to you. And many, many, many frequencies. And you are God. You have to create a system from randomness. So what you do is you take those frequencies and couple them together and build a system. So what in the horizontal axis is 1, 2, 3, 4 integer. Those are the number of small spheres or large spheres given to you. And vertical lines, blue lines, are the how many ways you can combine. Then what you can do is, after these combinations, you can rotate this by considering the total number of symmetries. For an example, if you divide me by half, you can find C2 symmetry. So this side, that side. C3 symmetry, C5 symmetry, C7 symmetries. C2 symmetry can occur in 50% of the cases. C3 symmetry in 16% of the cases. If you go on adding 47, if you go up to 47, that means 15 primes, you will be able to find 86% accuracy. So it means if my structure is created using this kind of mathematical architecture, the right side video, I have switched it on. You see the temple-like structure, which is made by all the probabilities, all the possibilities of combinations. Then what happens is, it doesn't matter how you create your combination of thoughts by using vibrations. I will be able to emulate and replicate it with 86% accuracy. And it does not limit to humans. It limits to universe also. If the whole universe is made of whatever it is, I don't care. But whatever be, how many number of primes, how many ways, how many complexities. But whatever it is, I will be able to emulate 86% accuracy if I am made of only 15 primes and associated dynamics. So we say that information must have integrated similarly, we're following this symmetry, so that I can emulate 86% of what's happening in the universe, so that I can fathom it. And there are other conditions also I will not get into, just integration-wise. I will finish it here. So triplet of triplet, we started seeing triplet of triplet. You see the triplet is there. So 400,000 integer, we saw the probability. And we found triplet. We zoom a particular part, we found again triplet. We zoomed a particular part, we found again triplet. So I started setting up an institute, and that is the logo of the institute. You see triplet of triplet in mathematics. That has pure mathematics, probability distribution. It has nothing to do with any biological system or anything. You just build it, okay, from mathematics. So you get the support that why should we get triplet of triplet. But that is prime number 2 and 3. What if there are, you dominate the prime 3, 5, 7, 11, and others. So you get 15 different kind of prime, temple-like structures. So I'm building them right now. So I feel like that could be one possible way of integrating information and how those nested spheres are generated. So this is the metric, mathematical metric, and you generate it by applying some operator, that is a trigger of noise. If you apply to this system, then the system emits or radiates a set of clock-like nested vibrations, and that we call polyatomic time crystals or the information content. Okay, in summary, so the information grows within and above. You have a phase sphere, then there are phase singularity. Inside the singularity, you grow some information, and you take one of the spheres and you grow inside. So far, Turing machine told us that what is the system? Whatever be the complexity of the information in the universe doesn't matter. I can write it on a single line, 01, 01, 01 bit like. That is the strength of Turing Turing principle. And then Shannon information theory is very, very, very strong. We have nearly 70, 80 years of history how computer scientists try to break it and go beyond Turing. And just like quantum computer today, Google says that we have achieved quantum supremacy. Within 1 year from China, another group says we solve the same problems faster than you in a classical computer, on a desktop classical computer. The same thing started happening in quantum science also, in computer science also. So many people, even when the IIT proponents came here a few days back and suggested that they believe in non-Turing, system is non-Turing, also Roger Penrose argued for non-Turing. Nobody has ever told you how, if it is non-Turing system, then what? Turing himself started proposing morphogenesis and other kind of proposal came. I met Stefania Bandini in 2010. In 1975, you know, there was huge movement that cellular automata generate non-repeating pattern, so it should be non-Turing. And she proved it is Turing. So anything that is defined is Turing. Anything that is defined. So you saw that in the presentation, IIT proponents were showing lots of equations, mathematics. Any kind of mathematics you do, with the Turing machine, you can emulate it. If you can emulate it with the Turing machine, operate it in Turing machine, it is Turing compatible. That's it. You cannot say beyond Turing. There was one book in 2010 written by Roger Penrose, Road to Reality. In that book, he argued the only way to go beyond Turing is going into the singularity and expand, and then finding singularity again expand, because you cannot derivative. You can't make dy dx, and then you cannot have any equation, and then you cannot do it with a Turing machine. That's the only way. So that's what you see here, that when we see that nested spheres are growing within and above, then it follows the Penrose mathematical condition to be non-computable in a Turing machine. Okay, so now I have completed the third part. So first part is you have create a vortex-based architecture. Second, you take a triplet helix so that the symmetry is there. That's the important thing, the device. And finally, you take the primes or the combinations of all possible states, not probability distribution. So the advantage of this kind of integration of information is that you are not biased by the human subject or human experimental design, because it's a combination of primes. So that is fundamental to the universe. And so this becomes, we patented it in 2016, this language to build computer. We call it geometric musical language. And then we started to think that we would measure this entire time domain. So now we have a big clock that could be a seconds clock. Inside that we have a microsecond clock, millisecond clock, nanosecond clock, picosecond clock. We have to measure. So now we are not limited by the neuroscience that was there for more than 100 years, which was arguing that in milliseconds, everything happened in milliseconds, 250 milliseconds, done. If I say that it is happening all possible time domain, I need to invent a machine to measure it, and I need to reproduce it. So I went on looking into the EEG, and I found that EEG is not enough. This whole technology has to reform, because EEG takes the signal and then we associate it with the ionic, but there are at least 6 points I have listed. These are copied from research papers published by others, who suggest that how extensively filtered, and it's a fancy device where you do all these kind of things. So you can go through those papers where they have argued that you take different kind of signals than what you should be taking. So in DDG, how the technology got different, so we have logic analyzer and a nanosecond pulse or picosecond pulse. And using that pulse, we find out what is the width of the potential that is generated on the surface. So that is the very simple one-line statement how you can make a DDG. Now, since your data in nanosecond time domain is 1 billion, so 1 billion data sets, images are getting generated, so you need to average, and if you send it to the computer, then computer takes milliseconds So you can't do it. So you need to make a purely analog system, a completely new hardware architecture to simulate it. But before going there, I would like to draw your attention to this particular plot. You see, ionic signals, suppose you have hundreds of papers published in the last 50 years that ionic EEG gets from neuronal junction fires, and that actually goes to the top. Actually, ions can never move to the blood barrier or ionic signal or kilohertz signal or hertz signal and a bone barrier. You see that if you open your basic textbook, you will find that ionic resonance happens up to kilohertz, and in the hertz region, it's very, very high. So ionic signal that is produced in your ions or synaptic junctions will go there to the top and feed the EEG. This is not possible. It is coming somehow else. And bone, if you see the bone, then it goes, it decreases towards the megahertz region to some extent and goes to the gigahertz. And if it is a gigahertz signal, and I have put a red line, wavelength too low. If the wavelength of the signal doesn't cross suppose it is created at the center of the brain, and it has to pass to the brain. So 14 centimeter is the brain diameter, if I see. 14 centimeter is the wavelength, then the corresponding frequency would be 2.4 gigahertz. So from 2.4 gigahertz to higher, the wavelength is very low. So you can't. You need another transmitter to bypass. That kind of circuit doesn't exist. So far we know the biology. That kind of booster circuit, booster transmitter that we see in our electrical transportation, that kind does not exist in the brain. So very limited time domain is there where we might get true brain signal in the megahertz domain. There is a possibility. I'm not saying 100% possibility, at least some possibility is there. So, and another thing is that when we physicists do the measurement, how many physicists are here? Can you raise your hands? Oh my God. Okay, don't kill us. Okay, so what we do is, suppose we want to measure a semiconductor. Then we take the actual device, then we take an identical device, but it's empty. And then we take a dumb material, dumb device, and we measure 3 of this. And then we compare. We call it normalization. This is how we do the measurement. Actual material measurement is impossible. Yes, so that's how I have been doing research for 25 years. But for brain or EEG, you directly measure it. Have you ever thought that how they are normalizing the data? They normalize data from the previous data sets they measured. Somebody else's brain, somebody else's average out systems. So that we didn't want to do. That's why we built the artificial brain system that is not conscious. And we went on. Second thing is that, so we consider the brain model. We do not consider that just neuron is doing the processing. The entire, every single component, wherever there is a helical symmetry, is contributing to the triplet of triplet, and it's connecting from the smallest to the largest organ. And we created a map. We published it long back. It's a repetition, but I'm just scrolling through. And so we have a large number of clocks. Somewhere down there, you can find a neuron. If you find it, be lucky. Just think that, I mean, we are not giving favor to anybody. I'm not giving favor to also microtubule. I'm saying whoever is a triplet of triplet symmetry, whoever calling, is contributing somewhere in the time domain. So number of neurons doesn't matter. If your brain is fully empty due to hydrocephalus, and then neurons are gone, if the sum of them are there to link the resonance chain, that's enough. So I'm making a spatiotemporal architecture going away. So if some of the neurons die, some of the new neurons are born, doesn't matter as long as your vibrational chain is secured. So this is the argument. So we went on creating the whole brain model, and you can find it in www.brainrhythm.org. In the website, we continuously freely upload, and all the components of the brain we went on, giving favor to nobody and considering every single component. Why should we give a special treatment to any particular component? If Christoph Koch comes, he will say claustrum. If Stuart will say microtubule, then some people will say hippocampus. Some people will say brainstem. So we take all we find, and we find the symmetries, and we create the database. So the brain becomes like this. So yesterday in the hall, I think Peter is here from Ghent University. So he created a hologram. So if you want to experience, yesterday some of you experienced, and those who have not, you can contact him. He is creating an experience that you can immerse into it, this structure, and you can feel how all these brain components are vibrationally coupled. So for the last 100 years, all the papers that were published on rhythms, who will connect it to what, which rhythm connects it to which one, we created, integrated them, and there. So with the DDG, we try to get a projection of this brain. So that's why I'm showing this. So this is the model on the top, and the bottom is the brain structure, actual, that we created. So if we have all the clocks and nested relative phase, so 47 different kind of helical symmetries we synthesized in our laboratory over the years, and we recreated the entire brain structure. So what I'm saying is that when we will measure your brain at different frequencies, how your conscious experiences or cognitive experiences are generating, I will have an artificial brain to normalize your data. I'm not making that brain to artificial brain to generate consciousness or something. I will be as close as possible as far as hardware is concerned, as far as vibration is concerned with you. And then I will filter out exactly the non-physical part that is making you conscious. That will not only give us that which theory of consciousness could be correct one, it also give much more insight about the cognitive experiences and our true nature of consciousness. So these are chemistry. I'm bypassing it. I think without Philip, nobody would be interested. Any chemist here? No. Oh, thank you. So these are the gel structures, and we shot light with it. And number B, you can see cavities in they are oscillating, and oscillations are there. And we check and optimize the structures with looking at the optical vortex emitted, just like we did it in real neural network. And we measure the resonance chain also. And we go on creating many such structure analogous to the components. And we build it in our laboratory. We let them talk. And there are many videos are there. And these are the primitive early days, long back, when we started. Now we have very sophisticated system. If you come to our lab, if any visitor comes, we put your brain and connect it with artificial brain, and we try to see that how many, what is the time domain where you can,
you have to look for a
where you
long
can
period of time
couple.
to see activity. Of course, in kilohertz, megahertz, and
Don't worry about my voice. Okay, so we also allow two artificial brains to communicate continuously, whole day and night. And this is extracted from our previous paper, that how do they communicate and which time of the day they communicate more. And the day we are lucky, we celebrate, we go for tea, because today they have communicated. So we don't have a control, complete control, but we are looking into the entire time domain. Entire time domain, from millisecond, microsecond, to nanosecond, everywhere what is happening. So we are not rejecting EEG. We are not saying that EEG is dumb. We are saying that in the entire spectrum, there is 1 or 2 snapshots where you could say EEG or milliseconds, but you have many things you are not seeing so far. Those were invisible. So we also invite the human subject's name is not there, but you can see that some of them, subject number 5, quite synchronized, and some of them did very good. So this is the DGG, actually whole brain spectrum, and blue means lower, and red means higher frequency. So there is one major difference in DDG. When we went on doing, we, like your EEG device, you have found that they touch on your back side of your ear, there is a bone. They normalize with that. But here, we took look at a clock here. Just when the baby is born, you have found that at the frontal lobe, there is a region where there is a dip sound you can get, the heartbeat, because whole brain vibrates very fast. So that part, nature does not create in the mother's womb. When the baby comes out, later, slowly, he adjusts the clock. Okay, fine. So we put one clock over there to normalize, and 2 blood vessels are going through these two places, we also additionally. So we have to take additional protective measures than EEG because we are taking the high frequency data. And when we look at the data, we see over time the snapshots of different frequency domain or time domain, the signature that is coming out. And this three-dimensional structure is the thought or the human thought or human perception that is shown in Xi. And what we did is not just one human subject or two human subjects, we went on increasing the number of human subjects, and we started seeing their information processing. For an example, and we put thermal camera, we observed every single way the signal transmission could happen. And we put it in a tensor mathematics, and we find out the planes of symmetries. Okay, that one is a photograph, there was a video. So there, at the bottom right, you can see there is a plane, so 3D, I will show you the video later on, that when you have a Turing machine, it's a 0, 1, 0, 1, right? So that's how the data is there. But when you have within and above, it is orthogonal to the Turing tape. You have a fractal tape that is going bottom, within and above. Then you need a completely new tensor mathematics and manifolds to express the information processing. You can't do it with normal bits and a cluster of bits. It's not that you go to the market and buy 1 terabyte hard disk and you plug in. That kind of thing cannot happen. And that can, just like quantum computer, in quantum computer you can't do this. You can't just plug in. Your entire thing has to be rebuilt and redesigned. So that is a problem. I mean, if I get time, I will get into that. So we went on studying large number of human subjects, not large, 289 human subjects to be precise, and we went on mapping where is the brain, is the gigahertz signal coming, and where it is dumping, which region are the best, what kind of human subjects are showing what kind of distributions. So this is a classic picture now. And here is the 12th order of time domain result that you get. So on the top left, you see EEG that you get from the classic EEG device when you used to see the brain signal. But with the invention of DDG, what we are doing from microsecond to nanosecond everywhere, what kind of signal that is coming out from your brain are being processed. We take a snapshot of 84 different time domains. And we find out the geometric invariance you find in number 15. That is in the picosecond time domain, because you know it's a thermal, so that kind of things are there. So once we get the data, what do we do with that? So we try to find out geometric shape that is invariant. That means what are the region what are most active, what are least active, and what kind of geometric shape do they make. So that we call invariant. And if we see a person is happy, for always the happy persons have this particular geometric shape in the spatiotemporal domain, that we consider as the signature of a particular emotion. But here is a problem, and here we need to change our mindset, because in EEG it was in the millisecond, in the seconds time domain, 1 hertz to 40 hertz. So we were very safe. So all almost same time domain. But in DTG, when we start seeing the human cognitive effect, we encounter a very, very unbelievable scenario. That's even for us, it was very difficult to trust. So I will talk about that. First, I will say what is invariant. Suppose a circle, you are rotating around the circle. Radius remains constant. So what remains constant, that we call invariant. So we say that nature does not look for all the data and do data processing. Nature has not recruited software engineers to do image processing. So what nature does is looks only for invariance, takes the invariance, look the variable and the invariant directly and do it. So we also thought that why not we should make a patent, or the invariant, you see that second class of invariant, third class of invariant. So many, many different ways invariant could be generated. Now, here is a summary of what we saw and why I encountered a life-changing experience when we were doing the human subject study. When we had a one subject and we put the DDG machine, we see that different time domain, suppose I play a song, different time domain, it is getting activated different part of the brain. But if I block two human beings, then I find that they are sharing the song. Okay, 3 human beings, that is the third column, then we see some kind of typical geometric shapes. In some time domain, some part of the song or some part of the rhythm is taken by somebody. Okay? And this goes on, and if I go to 8%, then first time I start seeing the topological invariance that I found that remains almost constant across the human subjects, and we can trust that data. So that means if I want to study cognitive or conscious effects or perception, one person will be very biased. We cannot, even with DDG, with a high, much more sophisticated instrument, it is not possible to gather a reliable, trustable data from one human being. At least 8 human beings is necessary. And if I want to see fluctuation and communication, we have to go 12 and beyond. And all of their brain to be coupled. Anyway, so the most interesting thing was when we saw this result, that their brains are connected, and with music they are different time domain. So I called my friend in UK, Martin. I told that we got this result. He said that first thing you have to do is to disprove it, because we are experimentalists. What we have to do always is to nullify the effect. So how can you nullify the effect? So what you do is fill the room with smell. So 8% or 12% coupled electromagnetic with DDG and EEG, all the entire setup, and we suddenly throw smell, beautiful smell in the room. And what happens is all of them are coupled doing the same thing, but using only 1-2 nanosecond pulse. That is the effect of smell I have put to that. It's unbelievable that all the people with 2 nanosecond pulse, so sharp. And then we gave them Indian sweet, halwa. If any Indian is here, they know. So halwa is very attractive looking, semi-transparent, and it looks fantastic. So we gave it to them, and their brain got disrupted. And we really saw their brain got disrupted. And then finally we asked them to touch their hands and asked them that you touch, and then we saw a very unique kind of dynamics that started happening, and they were not responding to the song. So don't touch each other's hand. So I will go. For 2 subjects, you'll see.
Earlier we had only one subject, so you can see the pattern.
Only 2
by
subjects,
both
you will
of
see only 2 lines get activated.
We see
So
only
here
2
I can
channels active
stop
here.
it.
So first we
So what we observe is with a thermal camera, we see it with normal pictures, with kilohertz, megahertz, and gigahertz. We observe the phase evolution and collective signal processing among all the human subjects. So we do that, and then we go to 8 subjects, and all of them are connected to with EEG. What you are seeing here is S1, S2, S3, S4 is the 8 subjects, and in horizontally is the nanosecond, microsecond, and millisecond, different time domain. So you see time also changes and subject changes, and their location in the brain also changes. But together they were playing with the bits. But that kind of signature you can never see when you will look at the EEG. Then we go for smell, and I showed you that single pulse. Look at the pulse. So the long pulse that was there for microseconds or hundreds of microseconds or milliseconds, they have gone, and you see discrete isolated singular. This is absolutely raw data captured by camera. No filtering, nothing. So because we wanted to discover, we wanted to understand concepts. We don't have to sell and go into the market EEG devices and make profit, right? So what we do is just observe, and then you see the pulses. It's and then it survives for a longer period of time. The duration also increases. And then we give food, and you see the pathetic condition of the synchrony. So as we give food, we see that width has increased entirely. So we can't classify the location spatiotemporal dynamics that are there. touch disrupts, and we went on finding the invariance. That means which time, space, and what are the geometric shape they do. So we have found 97 different conditions, and what are the geometric shapes that are happening. So all these, you are taking photograph, but it's all published in the book, and in my latest book. So entire book is there, 500 pages, all the data are there. In the website it is uploaded, all the data, and in the publication also, in the chapter also, everything is there. So you can just download and read, and most of the data are also in ResearchGate, so you don't have to pay, those who have problem in paying or not associated with institutes. So all different kind of functional cognitive responses we went on. Since I'm running out of time, I'm going there. So we give tests for different kind of geometric shapes. How is it associated with the brain signals? And then try to find out what are the numbers associated with the color. And we can give different kind of responses to the human subjects, and we can figure out the universal correlations. Say integer has color, color has test has something. So like almost like synesthetic patients, like they correlate. We try to find out the similar thing from the human subjects to understand the universal cognitive rules. Then we try to find out what are the prime sequences. The future work, if this part, two parts are new, so I have little time. So I would explain to you that yesterday I was in poster session, and one person I found that 7x7 and 25x25 tensors she created, and she took geometric shapes to tell a story. So she did it in 1997, when I didn't even thought that I will be a graduate one day. So we have to create a tensor similar like that, and we have to find out different imaginary worlds, say 12 imaginary worlds, so 12 imaginary numbers, and then we have to interact with them. So tensor algebra or higher dimensional tensor mathematics is the only way by which we can do the information processing, because addition, subtraction, or this kind of arithmetic doesn't work if you are growing within and above. So I can. So if you go to the higher level of tensors, you will find complexity increases manifold. And whenever you write the information by tensors, if you look at the homogeneous surfaces where the values are, they look like those kind of manifolds. And using this geometric musical language or clock architecture, we have created nanomachines. So what I wanted to tell is that if you know language of nature, you can do wonderful things. And if anybody claims to you they have understood consciousness or created a model of consciousness, or understood what is information in nature, ask them to build something so that they can create, send inside the human body and do not get any response from the protein. So we created this machine, and if you send normal drug, if you take even paracetamol, you will find 500, 600, 700 protein upregulation, downregulation. If you send this one, which we are GML and PPM with our language, we have modified it, we get 40 to 42 maximum or 5 to 6 highly expressed. So we feel like we have almost understood it, and you have seen human subjects or biological materials, they solve the maze problem. This kind of intelligent system also solves the maze problem, just like the top one, top right corner, you can see that PCMS can go and identify the cancer cells. So you can create it lifelike intelligence. And then we created computer, quantum computer, that is in our lab. This is the last thing that I would like to show.
Now in your screen is a,
so this is in our lab, the computer that you see, the GML I told you, the information processing microtubule does. So it all could be fake story, fantastic story, right? So best is you use that, make a computer,
and it is converted into a
and allow that computer to do wonderful things that normal computers cannot do. So we have patented, this is now operational in our system.
and there we can
And
convert it into a resonance
you
frequency
take the
band,
variation,
and
data
the
variation,
entire
and
data
convert it into frequency
actually
and
comes
phase,
here
send
to
it to
these,
the function generators,
which generate
and
the
you can do the chemical
and
processors
send
where
it
you can do the
to
computing.
So what you see now in your
So conclusions we made regarding DDG is neuron fires at 1 millisecond. Any activity faster than that seen in DDG cannot originate from neuron membrane. So microtubules and other filamentary substrates are possible reasons. Triplet of triplet resonance chain is real. It's classical but could serve as a base for quantum information processing when you connect it with a geometric phase. And correlates of human consciousness is not visualized in one human data. You need multiple different humans. And this is the group who worked for this human subject studies.
Thank you so much, Anirban, for this fantastic talk with all these amazing results. It's really great work. Thank you. Congratulations. We have time for questions, starting over there.
Thank you. Thank you, Anirban. I feel like we just witnessed a historic lecture here. My quick question is, between steps 3, integration, and step 4, self-awareness, you mentioned the role for Penrose non-computability. Can you expand on that a little bit, that little piece of it?
Penrose?
Penrose non-computability.
Ah, okay. So actually that goes to the historical journey. Ever since in 1952, before death, Turing started non-Turing machines. So that Turing machine says you have to write algorithm, you have to do something. And then can information come out of nothing and disappear into something, into oblivion, and then do dynamics and disappear. So that is called reaction diffusion system. So that started, then von Neumann, then cellular automata, everything came. But what Penrose are good, if you see the foreword of that book, he has written, I asked him personally, that you have written that every single thing described in this book has to go away, and a new mathematics has to come to explain consciousness and the mystery of the universe. I loved it so much. I mean, it's a 1,000-page book, very thick book. And so in that book, actually, he talked that how to create a state that is never defined. If you define it, if it has a finite value, any value, say a complex number, if just complex, no real part is there, e to the power I theta or something like that, even then you can run it in a Turing machine. It is so strong, so strong. So I feel very much pain when anybody comes out with a Fourier equation that this is non-Turing. Computer scientists have been dying of doing that. So Penrose's argument is that, as far as I understood, that if it is if it has a value, so dy dx is basically, if I explain a little bit, I mean, I pardon for technicality, limit f x plus delta x minus fx by delta x. So basically, you try to find out at two different point, functions should have a continuum. So Penrose has made a detailed discussion that if continuum, I mean, dy dx has to go through this limit differentiation at very limiting scale. This continuum could be redefined. If you break it and create it, again there is a problem. He has written it, lucid language. If you break it and recreate it, problem. But you change it into another continuum function. So fx plus delta x, it becomes gx plus delta x. Only if you can create a situation like that, you can get over and you will never find dy dx. If you never find dy dx, you are done.
Thank you.
I'm afraid we cannot take all the questions that I see here, but maybe 2 or 3, please.
A brief one. In all these levels of complex, impressive complexity, do you see anything that might be described as a chaotic attractor or unstable singularities?
Yeah, I would say that I could not discuss because I tried to present the technical things because we are going for commercialization, but I strongly believe that every part of it is singularity, because when we say it that we are integrating information within and above, we are taking a clock, finding phase singularity and going within. So it's a chaotic attractor of the singularity only, that is the only reality of this universe, of this mathematical universe.
Next question.
I'd like to be one of the first to congratulate you for figuring out the architecture of perception everywhere in the universe. I've been working on that problem, and I think we're alike. So this is a very detailed congratulations. I'm sorry I was curt yesterday when you dropped by the microtime praxis or the ultra bandwidth praxis room. But I love the fact that you are using only scientific principles. I don't see anything there in your principles invoked which would constrain life on Earth. So therefore, these computational principles based on the periodic table ought to apply everywhere. That's what I did. 30 years ago, I was Christoph Koch's student at Caltech in the physics department, like you. And I was the only neuroscientist I ever knew talking about sub-millisecond stuff. And so for you to double down on bandwidth, to double down on timing precision, on helical things, on data representations, on polygons coming out of number theory into the continuum, every single piece of that is a piece that you are much better at math than I am, and you're much better at experimental design than I am. But I recognize the problems, and I know that you have just explained a huge portion of what all of us care about. So thank you.
Yep. Thank you so much. I was wondering about the connection between your first part of results with the artificial brain and the second part and the resonances you showed there and the patterns, which are based, to my understanding, on structural properties at different scales. And the second part about cognition and emotion in human subjects and your DDG results, whether there is any, how the two connect somehow. How do we bridge these scales from the artificial brain that presumably does not do computation, and the and then the follow-up question I'll let you is whether we can get the deeper question is, can we get any insights with regard to the sort of constraints that computation might be using on top of structure, right? How function would emerge? Is it metabolic constraints you have emerging, for example? Is it efficient, surprise minimization, like some brain theorists talk about? So how do you go from structure to function, really?
Okay, so first part of your question, and that how do I correlate artificial brain with the normal brain? Because artificial brain results should be, so when I was young, I used to make artificial brain. I have many models. I created 3 out in the dustbin, created 3 out in the dustbin, so all became nonsense. But that time I was using only, sensors. I was giving a lot of stress on the sensors. The new generation brains that you are seeing, I have 4, 5, 6 brains, this liquid jelly, floating organic systems and all some things. They don't have any sensors. So I have stopped communication, only proprioception sensors is there. So electromagnetic field, sound, and other kind of field-based systems are there. So communication is not allowed, but allowed. So I have seen people, musicians, started crying because it also plays music. I have not played it, but it also plays music. It listens to you and it creates interacting something. And after some time, you feel like extremely depressed and in pain and something, and you start crying and you feel good, but those who synchronize. Some people don't synchronize. So right now, our situation is extremely primitive, very primitive. Sometimes it works, sometimes it doesn't. When it will work, just like quantum computers. Quantum computers, sometimes the entanglement happens, it gives results, sometimes it doesn't. After 2 hours, you add 2 + 3 = 5. Similar situation is there. So comparison with a human subject and their surprise is much later. I am very happy if I find one person is synchronized. For an example, Nicholas Berggren came to our lab last week, and then all temporal band of artificial brain and him synchronized. I just took the video. If I get permission later also. So I am at that primitive level. And then the second, there was any surprising things or not, I find human subjects when in group, a lot of surprising thing which challenges the fundamentals of neuroscience. For an example, when we presented the 200 to 700 nanoseconds, the maximum activity is happening in the individual brain or other's brain, and if you jump, dance, it doesn't change. With a human subject, it doesn't change. That's enormous surprising for me. From artificial brain, I have not got even a single thing that will amaze me until now.
Thank you.
Thank you, Anirban. We are already in overtime, so I can admit one question over there and then the final one there. Okay.
Hi, Ken Mogi from Tokyo. Thank you for your talk. So Roger Penrose and Stuart Hameroff have been suggesting that microtubules are working as quantum computers. And you said you are not favoring microtubules, but from your research, can you say something about the mechanism in which microtubules might do things like quantum error correction, which many people are thinking that is really fundamental in quantum computing and so on? So.
Yeah, so regarding quantum error correction, one thing we have to remember that that quantum error correction, if we have a bit-like operational system, bit or qubit-like operational system, when you have cable, error will build up. Every time you do the measurement, you do the transmission, and every time error will build up. You can't. It doesn't matter how many idler state you can do, how good technology you have to create a noise-free idler state. You have to create idler state, and every time you generate noise, and noise gets build up. In here, in contrast, the computing architecture itself helps. It is not just a microtubule or something. Here, if you see that we are taking the hologram, the holographic structures, which has 12 different planes and phase singularities, and those are working as a fundamental equivalent to 12 qubit or 20 qubit systems that are. But when I am adding new information structure, I am not adding those together to create a new topology. That phase relationship goes inside one of the phase singularity points. So it is just like putting a big ball in a desired hole. That is the computing principle. So that's how we are avoiding the building of quantum error. So error correction is happening due to the principle of quantum information integration.
Okay, thank you.
Please. Yes, thanks for a great talk. Can you say something about how the theory that you're just presenting could relate to interpersonal resonance, simultaneous similarities between two people's brain states?
Yeah, so what I did not present, I present only beautiful things. What the dark side of it is that many groups, they don't synchronize. Absolutely don't synchronize. Those are lost subjects. So we try many things. We try we even played pop songs and then some African tunes, Tibetan tunes, but some people don't. And some of the results are something like 2 hours of try to synchronize. If they don't synchronize, machine is doing there. No, it's not a human observation or normal psychology test. I have so many machine sensors connected to the brain, thermal camera observing and something. They are not synchronizing. So to me, so far, whatever experimental result I got, I found that, okay, this is non-scientific. Okay, so if some people supposed to synchronize, they synchronize within 1 and 1.5 minutes. If you couple their brain, boom. And those who don't synchronize, it takes huge and sometimes absolutely don't synchronize. And we can see the electromagnetic spectrum, we can find out cooperation happening between them. If 2 persons have similar food habit, they synchronize, desynchronize faster, and thermal radiations. So I have seen that if you take a thermal camera and 2 persons sit side by side and hold hand, left and left right, you will find the thermal heat flows in particular configuration. But with some persons, it doesn't flow. You will find dark region in the hand. It's not bright glow. The 2 persons are isolated. So I feel like persons are, that science I don't understand, but I have seen that some people are born to synchronize, some people are absolutely don't synchronize. Difficult.
So we are at the end of the session. I think let's thank the speaker once more. And now enjoy your lunch, and the next session will continue at 2 p.m.